Bob, the AI chip in your smartphone, has more neural network processing power than the Apollo 11 computer that guided astronauts to the moon. But Aviation 360's delay predictor still needs cloud GPUs.
That's incredible. How can my phone be more powerful than the computer that landed on the moon, yet we still need massive cloud computing?
You're about to discover the AI hardware revolution that makes intelligent systems possible, and why understanding processors, GPUs, and specialized AI chips transforms how you test performance in deployment scenarios. Note before we continue, behind every episode is a full week of work, digging into the syllabus, building Aviation 360 examples, and cutting the script. Hours of video editing until it's clear and useful.
If this saves you time on the job, a subscribe tells us to keep going and helps this reach more testers.
Thanks for supporting thoughtful, no-fluff training. Now let's get back to the lesson. Bob, our passenger sentiment analyzer, runs instantly on tablets, but training it might require 50 cloud GPUs running for 6 hours. Why does the same AI need such different hardware for different tasks?
That's really puzzling. If the AI can run on a tablet, why does training need so much computing power?
And here's another mystery. Our baggage tracking uses specialized AI chips for edge computing, our delay predictor needs GPUs, and our booking system runs on regular CPUs. Each system uses completely different hardware.
There must be something fundamental about AI that requires this hardware variety.
The answer reveals why hardware choice dramatically impacts testing strategies. According to ISTQB, AI systems benefit from specific hardware attributes. Low-precision arithmetic using fewer bits, like 8 instead of 32, large data structures for matrix multiplication, and massively parallel processing. Traditional CPUs aren't optimized for these requirements.
So that explains why we need different hardware types.
Exactly. CPUs have complex instruction sets with faster clock speeds, but only a few cores. Great for general computing, but not optimal for AI. GPUs have thousands of simple cores perfect for the parallel matrix operations that power neural networks. That's why GPU training is so much faster for machine learning workloads.
What about those specialized AI processors?
Google's TPUs, Apple's Bionic chips, Intel's Nirvana processors, and others like Mobileye IQ and Huawei Kirin. These are purpose-built ASICs and system-on-chip designs optimized for neural network operations. They're designed for specific AI workloads, not general computing. Some emerging processors, like neuromorphic chips, even use architectures that mimic brain neurons rather than traditional computing designs.
This explains our hardware diversity. Training needs massive parallel processing, but running the trained model needs efficiency.
Perfect understanding. Training requires enormous computational power to process millions of data points and adjust neural network weights. But inference, actually using the trained model, can run efficiently on specialized chips optimized for that specific task.
So our tablet sentiment analyzer uses a pre-trained model, while the cloud training created that model.
Exactly. The ISTQB emphasizes this distinction. AI-specific processors are most suitable for edge computing, which means running AI directly on devices like tablets and smartphones rather than in the cloud. We train in the cloud with powerful hardware, then deploy to edge devices with specialized, efficient AI processors.
How does hardware knowledge change our testing approach at Aviation 360?
Significantly. Based on ISTQB guidance about hardware considerations in test planning, our testing approach varies by deployment. For cloud GPU training, we test scalability and training time performance. For Edge AI chips, we test power consumption, latency, and memory constraints. For CPU inference, we test integration with existing systems.
And hardware limitations could cause AI system failures.
Absolutely. Memory constraints can cause model truncation, processing delays can time out user interactions, and hardware-specific optimizations can produce different results across platforms. Understanding the hardware stack, from edge devices to cloud processors, helps us test realistic deployment scenarios and plan our test environments accordingly.
This adds crucial performance testing dimensions to AI systems.
Next episode, we're exploring AI as a service. How cloud-based AI changes everything about system architecture, testing, and risk management. You'll discover why relying on external AI services creates new testing challenges.
After understanding AI hardware, I'm really curious about how cloud AI services change the testing landscape.
The AI as a service revelation will transform your approach to distributed AI testing. Subscribe to TestTactix for the complete ISTQB AI tester certification journey. We're mastering every aspect of AI systems,